Chrome tab. See if this works. Can everybody see this?
I can.
Yes, I can.
All right. Welcome to the ugliest slide deck you are going to see today. A little bit about my background. I started off as a developer, mostly in Java land, back longer ago than I care to think about. Over the course of my career, I've built video security systems like the kind of network DVRs that people use for closed circuit television and video security. I've built apps to sell condoms in Brazil. I've built document security systems used by large organizations, to do things like digital signatures. And over the course of that time, I've picked up a number of different languages and a number of different platforms and such that I've spent a lot of time with. I want to start off by saying I'm a big supporter of boot camps and just the notion that software development is just a tool, right? Like being able to code is a tool. What matters is what you do with it, what you build with it. I did not come to this field through the traditional, graduate high school, go to college, get a computer science degree, et cetera, et cetera. I came through it through really being asked to solve problems in a specific area and just turning to software as a tool to do that. So, the idea that you need to go do a 4-year degree to be somebody who works in the software world, I think is outdated. And I think that the boot camps provide a tremendous path for both professional and personal growth for the people that choose to go down those roads. With that said, right, they teach a lot in a very short period of time. And they're almost all focused on helping you get to the place where you can start to actually, put things out into the world, actually build working applications. And as such, sometimes there are some of the details of some of the languages that get lost. So the purpose of this talk, as was described in the meetup, is just to cover off like 4 or 5 things that sometimes get skipped over a little bit, but are just critical skills in JavaScript, mostly for the front end. All this stuff is also applicable to building stuff on the back end if you're working with Node or another one of the server-side JavaScript frameworks. So if you're an experienced JavaScript developer, all these things are going to come across as things you already know. You're going to look at this and you're going to go, duh. So this is very much that 101 level talk. So what are the things? I've just put 5 on here, right? And if you get really good at these 5 things, this will cover probably half or more of the type of code that you'd be expected to write in a front-end developer role. I'm not going to read them off. We'll just kind of go through them. But these 5 things cover a huge amount of ground. So the first one is if you're going to be working in a front-end framework, and almost everybody is, React is insanely popular on the front end. Probably most folks I know that go to some kind of a bootcamp program are learning React. Vue and Angular also popular for different reasons. But what all of these things have in common is that they're all dependent on a pretty complex set of foundational tools. Things like Webpack or Babel, depending on which one you're using. And when you start looking at that stuff from the point of view of building an app, it can be really, really daunting. I mean, the number of options these tools have are near infinite on their own. And when you start to combine them, you rapidly reach a level of complexity that is just too much for most developers to take on. So your front-end framework is going to have tools to do these things for you. And unless you have a really, really good reason not to, you should absolutely use those. First of all, they take all the pain out of setting up a build, setting up an environment for this application. Secondly, they encapsulate really what are the best practices for each one of these, right? And the way you might structure a React app or a Vue app or an Angular app is very different. So, these tools, which often come from the people who develop the frameworks, are really the best way to make sure that you've got a sane structure set up from day one. Second thing, JavaScript object basics, right? So one thing that's sometimes confusing to folks when they first start out, with JavaScript and with building things is, well, what is an object, right? We know what an object is in the real world. It's a notebook, it's a mug, it's a table. But what is an object in JavaScript? And this is kind of a simplified definition, but essentially they're just a group of key value pairs, right? Like when you create a JavaScript object, it has properties, which are things that object contains. Each one of those properties has a name, and that name is the key, right? So if you're thinking about think about it like a table, right? You've got a key in one column and a value in another. And then each one of those keys, has to map to some kind of value. Pretty simple in concept and pretty simple in practice. Interestingly, though, because those keys are really just a list of values themselves, right? Each key has a name. You can access those values in several different ways, right? And I've got a couple of different examples here. So the first one, this dot notation, is something that I think almost everybody has seen before, right? Object dot property, and that gives you the value, or you can use the equal sign to set that value. But because the properties themselves are actually just an array of those keys, you can actually put the key in as a string inside of the square brackets and do exactly the same thing. So these 3 lines of code here, where we're setting the name with dot notation, we're setting the name with bracket notation, or we're putting the name property into its own variable, and then we're using the variable in the bracket notation. Those are all exactly the same thing. So we use this a lot if we have several types of objects that have common properties, right? So for example, at Conserve, we have the concept of a location, which is like a building, a space, which is a room inside that building, and then a sensor, which is a sensor that's inside that room. All of those things have a name property, and all of those things have a UUID property. So we don't even have to know necessarily what kind of object we're dealing with. We know that if we pull in the name property, we're going to get that thing's name, or if we pull in the UUID property, we're going to get its ID. It's also important to note that object properties can really be anything, right? An object property can be a primitive, like an integer value or a Boolean true false. Those are called primitives in JavaScript. They can be an array of things, right? They can even be another object or a function. So one of the things that's both powerful and dangerous about JavaScript is that out of the box, it doesn't really enforce a specific structure for your objects, right? You can really just add a function to an object, any random object that you happen to have, just by defining a new property and setting that property value equal to a function. So it's not really typed, right? Like if you were to be using a typed language like TypeScript, you could limit what properties get assigned to these objects. But for the most part, these objects are infinitely alterable and mutable. Very powerful, but also very dangerous because there's no guarantee that an object is going to have a specific property because you don't necessarily know what type it is, right? There's not necessarily a class assigned to that. The next thing on the list here is dealing with lists of things. I think everybody here has built the basic to-do list app, right? Pretty much every app on the planet is going to deal with lists of things. This is an example from the Conserve user interface where we define environmental levels that are appropriate for different types of locations within a museum. Each one of those level profiles has a name. It's got a set of values associated with it. So like, what's the right temperature range for this space? What's the right relative humidity range for this space? And all of those things are just handled as lists of objects. So in JavaScript, we've got a number of just like super handy methods for functions rather, for dealing with lists of things. So let's just look at like a list, right? This is a really simple array. You know, we've got this to-dos array. Each to-do list item has an ID. It's got a name, a description, and a priority, right? Like how important is it to do this thing? Fairly straightforward. You've probably seen a data structure like this in almost every app that you've ever built. If we have a list of things and, you know, we need to do something for each one of them, right? The array has this for each function. So if you call todos.forEach, anything that's inside those parentheses, right? So is going to be called one time for everything that's in your list. So if you do todos.forEach, that arrow function that comes after to do here is going to happen one time for every to do item in the list. So in this example, it would just very simply write out each one of those objects in turn to the debug console. We use this a lot if we need to go through and process a whole list of objects. So for example, when we get sensor readings back from our API, you know, we'll go through and we'll just iterate over that list, and maybe we'll take a value out and we'll calculate an average, for example. So this does not modify the initial array of objects. It just calls one function, and for each object in the list, it calls that function and passes in that individual item in the list as an argument, or as a parameter rather. We can also sort items this way. So if we have a list of things and we need to sort them, you know, the way we do that is very similar to what we would do for each. Just instead of for each, we just put in sort. The function that we pass into the sort is going to take two objects as parameters, right? So thing one and thing two. And the only thing that our function has to do is tell us which one of those two things comes first, right? So if we were sorting things by alphabetical order, for example, you know, we would want to have something that started with an A come before something that starts with a B. Or if we're sorting them in numeric order, right, we just want to make sure that we tell this function needs to return which object comes first. So for this example, right, we can see that if we return less than 0, then that's telling it that thing 1 comes first in the list. If we return greater than 0, thing 2 comes first, and if we return 0, then the two things are basically the same order in the list. So because we're sorting numeric values here, right, we want to sort it by priority. All we have to do is take the thing 1 priority, subtract the thing 2 priority, and that will give us a negative number if the thing 1 priority is lower, or a smaller number rather. And what we end up with is a sorted array. Now, when we do this, the array gets actually sorted in place, right? So we're not actually creating a new copy of the array. We're just taking the one we have and we're ordering those elements according to whatever this function that we provided tells us the order should be. You'll use this a lot, right? If you have like a table of things. So if we were to skip back up here and look at like our list, you know, if we wanted to be able to sort things by profile name, right, we could attach an onClick to this profile name and then take this list of things and just sort it by the name property. And then we could allow users to sort this list in like ascending or descending order. Another really common use case, right? And let's go back up to, oops, sorry, why is my slides not changing here? Oh, there we go. Another really common case is where we might need to filter this list. So we've got a drop down here, right, that lets us pick, you know, which spaces do we want to see. So in this case, that would tell us which ones of these level profiles or these entries in the list we want to be able to show. So JavaScript has got a super handy function built right in where we can actually just take that same list and filter it. And this one is actually going to give us a new array, which contains just the objects that match that match or that are returned rather by our filter function. So again, the same syntax, right? We're taking the array, we're calling the dot filter function on that array, and we're passing in a function that checks to see, should the thing that I'm just looking at now, this individual to-do item, be a part of the filtered list? So in this case, right, we're looking at all of our to-dos, and we only want ones that have a priority of 1, right? If the priority equals 1, then that's going to be part of the new list. Otherwise, it's going to be discarded. And then there's a shorthand version of that written right below, right? So a slightly shorter way to write the exact same function. Anytime that you have a list of things and you want to show a subset of the list in the UI, the filter function is a great way to make that happen. This last one is a little more complicated, but I think it's also probably one that is most familiar to folks that have gone through some React training. Starting with the same list, right? If we have a list of things and we want to transform them into other things, right? So maybe we have a list of all of our to-dos, but what we really want is an array of all of just the name properties, right? We just want a list of the names so that we can stick that list maybe in a select box or in some kind of other dropdown. The map function does exactly that. So it's going to call whatever function is inside of map one time for everything that's in our to-do list. And inside of that function, we're going to return whatever we want to transform this thing into. So for our example here, right, we're calling the to-dos map function, and we're just returning to-do.name. And what this is going to do is create us a new array, a new list, right, that just contains the names of all of the to-do items that were in the array that we started with. Where you see this a lot in React is where you are rendering a list of components, right? So if you have a list of to-do items and you want to display them in a table, for example, the map function is a great way to accomplish that. So you just call todos.map, and instead of returning an object here, we're returning a React component, and we've given it a name property, which is the name from our to-do item, and importantly, we've also given it a key, which is our index value. So again, in React world, you see this all the time as a way to take a list of things and render that list in the browser. Do we have any questions so far before we move on to the next topic? Nope, not a one. Okay, no hand raises. Great. Okay, so that covers our first two, right? Making sure that you're using the tools your framework provides you. The first three things. Some basics around JavaScript objects and working with lists of things. The next one is promises. I fully admit when these things first popped up in JavaScript, I was a little confused. I was like, wait a minute, it's a promise. No, I just told you to do something, just do it. Don't promise me you're going to do it later. But that's exactly what a promise is, right? A promise is just a representation of a thing that we're going to try to do. So, a real world example, right? I might promise you that I'm going to go feed the cat. If I can do that, right? Great, success. Maybe I'm locked out of the room, or we're out of food, or some other kind of condition happens where I can't do it. Well, then I still need to tell you that I made you this promise, but I'm not actually able to fulfill it. So promises provide us with a mechanism for doing that in JavaScript. One of the first places that you've probably seen this, if you've ever taken a React course or other kind of class where you've used the fetch API, right? So you're going to fetch a URL. That is working with promises. So when we first tell fetch to go get me this, whatever is at this URL, right, to make an API request for me, I'm going to get a promise back, and the state of that promise is pending, right? Which means, yes, you asked me to do a thing, but if I have to go out and request some data from another server somewhere out there on the internet, who knows how long that's going to take, right? Like that could take, 100 milliseconds. It could take 2 minutes, depending on what exactly we're pulling in. Once we know the status of that API request, right? Like the server has come back to us and said, yes, you asked me for some data. Here's your data. Or the server says, you didn't ask me right, or there's nothing there. So I'm going to give you an error message back instead. Then our promise has a state, right? Which is either resolved, I was able to do the thing successfully, or rejected, I was not able to do that successfully. So when you really think about it, it's actually a pretty simple structure. I'm going to ask some function to do something for me that takes an indeterminate amount of time. Might be a second, might be a minute. I'm going to get back a promise that, yes, I will tell you how this turned out. And then at some point in the future, that promise is going to become a real thing, either the data we asked for or an error telling us why we couldn't get it. So when we create these, right, the anatomy of these things is actually pretty simple. So when a promise gets created, right, and you can write these yourself. Obviously, you're not just using these coming from other APIs. If you have something that might take a long time to do, a promise is a great way to kind of wrap that up. But the promise, when we create a new promise, we're going to give it a function that takes 2 parameters. And each one of those parameters are themselves also functions. So we're going to give it one that we call when this promise is resolved. So that means that we were able to successfully do something. And then we're going to pass it another function that we call if for some reason we can't do the thing, right? So the logic here is pretty straightforward. I mean, if we can do the thing that this promise is talking about, then we're going to resolve the promise and we're going to pass the result back. Otherwise, we're going to reject the promise and we're going to give back an error, hopefully a useful one, right? Like telling us something about why it couldn't be done, or some kind of an error message or an error code. So here's a more concrete example using fetch, right? So the fetch API does return us a promise. So we're going to call fetch. We're going to tell it to get some data. After that, we see the .then, right? So anything that's inside of .then, the .then gets called when this promise is successfully resolved. So if we manage to get a result or get some kind of a response from this URL, that's going to be in that result object. If for some reason we got an error, then everything inside of the .then function is going to be skipped, and it's going to go to the .catch instead. And whatever error we pass back is going to show up in that error object. One thing you don't see a lot in the examples online of promises is the third option here, .finally. Anything that shows up in finally, the finally function is going to be called regardless of whether the promise was successfully fulfilled or not, right? So that's a really good place to put like some cleanup code, or if you have some type of a Boolean value that indicates, did we actually complete the request or is it still waiting? The finally function is always going to be called whether that promise was successful or not. So these are really handy. This is a very clean way to build this sort of logic, much cleaner than callbacks and some of the older ways that people would do these things. Promises can also be chained, right? I don't know if anybody's ever heard of this thing that people refer to as like callback hell, right? Where you have a function that has a callback that happens when something is successful, but then that function may also need a callback, and you end up with this very complicated structure where you have all these different callback functions, kind of like Russian nesting dolls, all tucked inside of each other. Because the way promises are structured, we can actually just return another promise from inside of our then function, And then we can just chain all of these things together. So when we call fetch, the result that we get back is the response from the server, but we need that result in a JSON format. So inside of our first then, right at the end of the first line of code here, inside of there, we can call result.json, or we can return that rather, which actually returns another promise, right? And then on the next line down, we have the .then again, which is going to give us our actual result as JSON. And now we have the JSON version of our request. So chaining promises together is a really powerful way to take a whole bunch of steps, all of which return promises, and just chain them together so that they complete in a sequential order, right? So we first fetch the API. When we get that result, we convert it to JSON, and then we call something else and handle our errors. One other thing that we don't see a lot of in some of the tutorials around promises is what happens if I have to call more than one, right? So depending on what you're building, sometimes you may need data from more than one API or more than one endpoint before you can actually show the user what you're trying to show them. A good example of this is, we use HubSpot for a lot of things at Conserve, and sometimes we have some data coming from HubSpot and we have some data coming from our own API. And in order to update a user in HubSpot, we really need both pieces of data, right? We need the user's current properties in HubSpot, and then we need some data that they've entered into our form so that we can take those two pieces of information, merge them together, and then use those to display something to the user. So to do this, right, we're actually going to create more than one promise. So we'll create this first one where we fetch one API, we'll create a second one where we fetch another, and we'll put both of those promises into an array. Once we have an array of those, we can call promise.all, and what that's going to do is that's going to wait for all of those promises to be completed successfully before we move on to the next step. Again, really powerful if you have multiple things that you need to do and you need them all to complete before you can do the next thing. Beyond the fact that it's going to give you a list of results, the structure is really similar to just calling a single promise, right? It's still .then and whatever results we got back, and .catch to handle some of the errors. This is a relatively new feature that I've also found to be super handy. Sometimes we might need to do multiple things, multiple requests. But if one of them fails, it's not really a big deal, right? Those two requests aren't necessarily dependent on each other, but we want to make those two together just to simplify things. The first part looks the same, right? We're going to create two promises from two fetch calls. We're going to put those into an array, and then we're going to call promise.allSettled. What this means is that the then function here is not going to be called until all of the promises have been completed, whether they were completed successfully or whether they failed, right? So this is a really handy way to group multiple requests together. And then inside of promise.allSettled, you can decide what to do with each one based on the status of that result. So some folks have also asked me about async await. You see this a lot in some of the fetch examples, right? This code is really, really simple. We're going to create a promise from fetch, and then we're just going to await the completion of that promise. And then at the end of it, we should have our result. What this really does is make some of this asynchronous code look to the developer a little more synchronous, right? So essentially execution is going to pause, like your script is going to pause, waiting for that fetch promise to be completed. But under the hood, these are all still just promises. So, all of the same techniques you use for dealing with promises, you can also usually wrap those up in an async function and use async await if you find that easier to understand. I don't particularly have a preference here. We use a lot of libraries that assume both, and functionally, they're really not that different. Oops. All right, the last thing that I've seen trip some folks up is references versus values. In JavaScript, when we call a function and we pass something into that function, the only things that get passed in as a value are primitive things. So again, think integers, string values, Boolean true false kind of things. If it's anything other than a primitive, and that would mean it's some kind of an object, it's going to get passed in by reference. So what that actually means is that if you pass in something into a function, like an object, right, and you modify that object inside the function, you're modifying the original object that you passed in, right? So you're not actually creating a copy or doing anything like that. This can lead to some unintended results. If you are passing something into a function and you make some change to it, and that same object is used somewhere else, well, now because that was passed in as a reference, everywhere that object is being used is going to now have the same new values. So again, if you're using an object in multiple places, just be aware that, unless you explicitly do something to copy it, when you modify it, you're going to be modifying the original object. This is because when JavaScript stores an object, it stores one copy of it. And when we pass that object into a function, what we're really telling that function is, here's where to find the object that we're talking about. We're not actually passing in the object itself. We're just passing in a pointer or a location of where that object exists. Now, if you need to create another, basically another copy of that object, right? There's something called the spread operator, which is super duper handy. It's just an ellipsis, right? Like 3 dots, dot, 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 and then the name of the object that you want to copy from. So you can see that on the last line here, where it's let a person copy equal dot, 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 a person. What that's going to do is create a new object, assign it to the a person copy variable, and then it's going to copy all of the properties and values from a person into the copy. Now we could modify the copy all we want, and the original person object that we passed in is going to be completely unmodified. This also has implications for testing whether things are the same, right? So when we test, is 1 equal to 1, right, in JavaScript, we know that's always going to be true. If we set 2 variables equal to the same numeric value and we compare them and say, are they equivalent, we're always going to get true. But with anything more complicated than a primitive, that's not the case at all. So let's just take these 2 examples, right? We have 2 person objects, we have 2 arrays. Both of them are exactly the same. They contain exactly the same values. But because we created them separately, and they're both pointing to 2 different object references, if we were to test and see, are those 2 things equal, JavaScript is always going to come back and tell us, no, they're not. Because what JavaScript is testing is, do those 2 objects point to the same reference or not? And because we created them as 2 different objects, they're not going to point to the same reference, and they're not going to be equivalent values. So there are some helper libraries out there that can do shallow comparisons, go through all the properties and tell you, do they have the same values, or go through an array and tell you, are all the array values the same? But if you just use the default JavaScript equals checks, those are always going to give you a false return. One last thing, I'm sure some of you probably noticed how inconsistent the code styles were in the examples here. Don't do that. One of the things that helps a team grow is having some consistency in code style. I am bad at this personally. So this is like an area of self-reflection and self-improvement. But if you come up with some consistent ways of naming things, whether you choose to use like camel case or underscores, I'm not real prescriptive about what they are, but what's important is that you apply them consistently. And that is it. I know that was a lot to digest in a very short period of time.
But so good. Did we lose him? Did Nathan go? Okay.
No, I'm still here. Yeah, I think I'm still here.
Weird things happening in Teams. That was awesome. Questions? Anybody? I also have gift cards to give away. So hang on before you leave. I definitely picked up a few things that I had forgotten about promises that I don't use, and then that promise is all settled. That is not something that I've gotten to play around with yet. So thank you for that.
Yeah, they've added some neat stuff to promises lately. All settled, and I think there's also another one that promise.any, which will resolve successfully if one out of a whole set of promises completes. So like promise.any, if you give it 10 promises, only one of them has to be successful for that to resolve correctly. I'm not sure when I'd use that, but it's there.
Yeah. Good to know. Well, thank you so much. Before I lead us into something else, I want to make sure any other questions, thoughts, comments?
Hey, as far as you mentioned a couple of the different frameworks early on in the conversation. And, as we know, a lot of these come and go with both in adoption, usage, and in terms of community support for people continuing to build, just, general support networks. What do you find right now is trending in a more positive direction as far as adoption and community support?
Man, I am like the worst person to ask that question. I think the first thing that you said is the most important thing. And that is that it's all evolving so fast, right? I am personally kind of a React fan. It's just enough of a library that it helps me be really productive, but it's also just lightweight enough that it's not so prescriptive. I feel like it's making me do things its way, right? But I mean, React has tremendous momentum still. The platform is evolving really fast. There's a ton of expertise out there around it. I wouldn't hesitate to recommend it to somebody for a new project. But again, there's a lot of stuff in the JavaScript world that just moves so fast. I mean, between trying to like run a startup and do a bunch of stuff on the server side, I am not as up to date on like the latest front end developments as I should be. Now, if you look in the are you in the Magic City Tech Slack?
Oh yeah.
David Lormore posted something a few days ago about the annual JavaScript survey. That might be a really good place to look, because they survey like hundreds of thousands of developers and kind of get their opinion over time about what they think about certain things. That might be a really good resource for you.
Cool. Yeah, I hadn't seen that post yet. I'll definitely check that out. Thanks.
Yeah, I'll put that link up in the chat here. That's a really good one.
Yeah, it seems like generally naive observation, from my perch at least, it seems, Birmingham, the startup community and the small business community, people who are a little more, I guess, agile and growing and exploratory, React I feel like I hear it come up a lot more, and I feel like that at least has our community's interest. And then I feel like, anecdotally, Angular to me seems like it was the darling, maybe years ago, but now seems to be in a pretty good place inside of enterprise, I guess, through kind of coupling with .NET, but that's just at least what I've observed. It seems to be kind of culturally different support networks there. But yeah, I'd love to look at that survey that Lamar did.
Yeah, where Angular lost me was the breaking changes from the first to the second versions. We had been at my last company, we were working on building out a whole new user experience that was really component based, so that our customers could use our components to assemble their own apps. And we made a tremendous investment early in Angular. And then Google just went and said, you know what, we don't like that. We're just going to break everything. Now that was a while ago, and it's remarkably stabilized since then. But that's kind of what pushed me out of the ecosystem, was that one to two set of breaking changes was just killer.
I love React's community. I just feel like there's so much support, and the React team themselves are just really involved. Most of them are from the open source world before joining the React team, and just do a lot to provide things for the community. And I've just really enjoyed that. So cool. Other questions?
Yeah, I know that presentation was dry and fast, right? But I would just like to offer, if you are doing this kind of development and you have any questions, I'm on Magic City Tech Slack. Feel free to just ping me and say hi. I'm never too busy to answer a question from somebody.
Awesome. And Nathan is good on his word there for sure. Appreciate his involvement just in the community. Nathan's been a long time supporter of Base, and just for the technology community in Birmingham. So thank you to that, Nathan. And if you're not on Magic City Tech Slack and you need to be, or you want to be, let me know, and I can get you an invite if you're having trouble finding it. I didn't realize there was no chat that I can find on this thing. So I can't put a link there, but I'm going to send out a follow-up email through Meetup after this. So if you didn't RSVP, you can do that after the event. I think you still can. Then you'll get my email, and I'll fill it with some links and resources, and then a link to the recording as well. So thank you all so much for taking some time out of your day to join us. And oh, good, Justin made it. We'll let Justin, and he went away. Still there? I didn't know if he wanted to do his little spiel before we leave, but Churn Micro is a great supporter of Birmingham developers. They have some great security tools and some free trials for you to use as well. I'll send those in my follow-up email as well. So thank you all. Have a great afternoon and rest of your week. See you next month on the third Thursday, and watch out for postings about what's coming up next. See you soon.
Cheers.
Thanks a lot.
Everything go well?
Yeah, I didn't realize there wasn't a chat. So
it's called conversation. It's called meeting. You have to go to conversation.
I don't think I have access to that unless I'm.
Well, Rachel could type in it. It's weird. Teams is weird.
Yeah, I'm wondering if I'm
available, some of the applications, etc.
Okay.
And then lastly,
I see now. So it's like separate from the window itself.
Yeah, it's super stupid.
Oh, I see it. And nobody said anything when I said that that I couldn't find the chat, but
That's because tech people are awful.
no. I'll just follow up.
Did you get your 4 winners?
On Meetup. I picked them, but I couldn't communicate. So what I'm going to do is just contact them through Meetup to get information. So I'll send that to you.
Okay.
And then if you'll just send me the recording, and actually we should probably stop the recording.
Need to stop it, yeah.
Yeah, it went really well.
Good.
Exploit is coming over the network
Stop
to target that device. You can